today. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are the bases. The parallel sides are the bases. All right, an isosceles trapezoid. If the legs are congruent, then the trapezoid is, oh, I spelled that wrong. That's all right. Is an isosceles trapezoid. So let's just draw a quick picture to define the bases and the legs. Which one here is the bases? The parallel ones, the top and the bottom, right? That's a base, and that's a base. If that's true, then where's the legs? Yeah, these are called legs. And in an isosceles trapezoid, they are congruent. Okay? All right. The mid-segment of a trapezoid. It is the segment that connects the midpoints of the legs. Just like the mid-segment of a what? Triangle, sort of, right? All right, a kite. Don't you want to go out and fly a kite? Just think of summer. All right, a kite. I got you distracted. A kite is a quadrilateral that has two pairs of consecutive congruent sides. Consecutive congruent sides. We're going to draw a picture. Opposite sides are not congruent. So, if we draw a kite, let's say we draw a kite like this. A kite has two pairs, excuse me, can you stop? Okay, consecutive means the sides are kind of next to each other, right? So that means that these two sides would be congruent if it's a kite, and then these two sides would be congruent. But the opposite sides are not congruent. See what I mean? Okay, all right. So let's go through the theorems here. If a trapezoid is isosceles, then each pair of the base angles is congruent. Okay, so that means that this angle is congruent to that angle. And then this is also a base angles, so those are congruent to each other. The next one is really just the converse of this theorem. It says if a trapezoid has a pair of congruent base angles, then you know it's an isosceles trapezoid, which would tell you what else? The legs. Yeah, it would tell you that the legs are congruent. Okay. All right. A trapezoid is isosceles if and only if its diagonals are congruent. So let's label this A, B, C, D. And we're going to draw these. So if it tells you that BD is congruent to AC, then you know it's an isosceles trapezoid. Okay? The midsegment of a trapezoid is parallel to its length and is 1/2 the sum of the lengths of the bases. So I'm going to label this one A, B, C, D. It's just too much commotion. Okay? And then I'm going to say that this is, I don't know, E, and this is F, and I'm going to draw a midsegment. We know that these are all parallel. The midsegment has to be parallel to the bases. And what this is saying is the midsegment of the trapezoid is parallel to each base, and its length is 1/2 the sum of the length of the bases. So I'm going to say, okay, if I add segment BC plus segment AD and cut it in half, That'll equal segment EF. Okay, if a quadrilateral is a kite, then its diagonals are perpendicular. Okay. Let's try and draw a kite here. Then we can say its diagonals are perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So that means only one pair of opposite angles are congruent. So I'm just going to mark that on here. Which pair do you think it is in this one? It's probably these two. That's what I would guess. These two are not going to be the same because their side lengths are different. So that's kind of just pictures of what you know so far. All right, let's turn this over. Actually, just go to the next page. So you've got some points to plot there. Go ahead and plot those points. And label them. Don't forget to label them. Trapezoid. Show that it is a trapezoid. What do we need? What do we know about trapezoids? Right. So if we can prove that these are parallel, then we know it's a trapezoid. And how can we prove that they're parallel? Right on. Okay. Compare the slopes. So I'm going to find the slope of YZ first. Now you can count, rise over run. If you have the graph, that's easy, right? Or you can use the 2 points. So for YZ, I'll just count rise over run. I'm going down 1, 2, 3. So that's -3 over 1, 2, 3, 4, 5, 6. -1/2. Right? Okay. So let's look at XW slope. Now let's use the points just to refresh your memory. How do you find the slope? You subtract the what? Y's over the... Right. So if I'm doing X and W here, it doesn't matter what order you go in. So I'm going to do 1 minus -3 over -2 minus 6. What happens here? They become plus, right? So it's 1 plus 3, which is 4 over -8. And what do we get? So, since yes, we can say yes, the pair of opposite sides are parallel. So we've proven that it is a trapezoid. Cool? Not bad, huh? All right, let's look at the top of the table in the diagram is an isosceles trapezoid. If it's an isosceles trapezoid, I know this. I also know that this is going to be 65, right? Okay. If this is 65, how can I find O? Exactly. So I'm just going to write down what I have to prove here, what I have to show. So I know that P is 65. I know that O would be 180 minus 65, which is going to equal 115 degrees. And if O is 115, then N is also 115 degrees. All right. In the diagram, HK is the mid-segment of this trapezoid. Find HK, the length of HK. So what do we know about that?
Like you add the bases together and then
That's it. Add the bases together and divide by 2. So HK is equal to 1/2 18 plus 6, which is equal to what? 12. You can add, that's 24, cut it in half, it's 12. All right. In the trapezoid JKLM, J and M are right angles, and JK is 9 centimeters. The length of the mid-segment NP of the trapezoid JKLM is 12 centimeters. Sketch JKLM and its mid-segment. Okay, so I know that JK, I don't know where L is going to go, I'm just going to put it here. So I know that J and M have to be right angles. And I know it's a trapezoid, not a square. So I'm just going to extend this side like that. I know JK is 9. And the length of the midsegment NP of the trapezoid JKLM is 12. Now, be careful. I kind of thought, well, maybe it's like this. Why is it not like that? Right, that's the main reason, okay? The midsegment has to be parallel to the bases. So that means that my midsegment has to go like this, doesn't it? See? Tricky, tricky, tricky. So now these are parallel, if it's the midsegment. And then how long is, let's label this NP. How long is that? They told me, right? What is it? 12. So this is 12. Okay, so that's my, that doesn't look like a very, that's 12 right there. So sketch the trapezoid and its midsegment and find ML. So we need to find this side. Okay, so I know that these two sides added together and cut in half equals, I'm going to write this better so you can see it better, that's 12. Okay, these two sides added together, cut in half, equal 12, correct? So just write what that says. I know that these two sides, 9 plus ML, cut in half, equals 12. You could distribute that 1/2, but that's kind of a pain. Let's just get rid of that 1/2 by multiplying both sides by 2. Multiply by its inverse, right? So if I multiply both sides by 2, I get 9 plus ML, which equals 24. And then ML equals what? Yeah, 15. Cool? All right, let's keep going. What? Oh, explain your answer. Oh, yes, I wrote that. So I wrote this. The midsegment has to be parallel, parallel to the bases. And then you use theorem 8.17. It's kind of what I wrote. All right, find the measure of angle C in the kite shown. Well, what do we know here? What do we know about kites? Yeah, these are congruent, these are congruent. What else? There's one pair of congruent angles, right? Well, it's not these, so it has to be these, correct? What else do we know about a quadrilateral? Yes, they add up to 360, don't they? Quadrilateral adds to 360. So I am going to use theorem 8.19 here, and the fact that quadrilateral angles add to 360. So if I do 360 minus 84 minus 140 and cut it in half, I'll have my answer. Because these angles have to be congruent. And when I do that, I find out that the measure of angle C is 68 degrees. All right, so here we go. In a kite, the measure of the angles are 3x, 75, 90, and 120. Find the value of x. What are the measures of the angles that are congruent? Okay, again, so what do we know about a kite? Two angles are congruent, which is what we have to find. The sides, do the sides help us at all in this problem? No, but what do you know? A kite is a what? Quadrilateral, correct? What do you know about the angles of a quadrilateral? They add to 360. So it's really just an algebra problem, okay? We know the angles add to 360 because a kite is a quadrilateral. So I'm just going to do 3x plus 75 plus 90 plus 120 equals 360. When you do this little bit of algebra, you get 3x equals 75. And what does x equal? Okay, so that means that if I multiply by 3, this angle right here is going to be 75, right? So do I have another 75? Yeah. So with the measures of the congruent angles are 75 degrees. Cool? Very good.